All right. So I started very late today. Um, well, there is a lot of things that almost there were a lot of things that almost prevented me from recording today. But yeah, here we are. Okay. Um, just trying to plug in quickly. All right. So I started studying on stacks yesterday, and we learned. I learned that stacks have some basic operations such as pop, push, at least not basic per se, but like key operations as it is written here, which are push to add an item to the top of the stack, pop to remove an item from the top of the stack, to pick is to return the topmost element without actually removing it, right? It's just picking, seeing what item is at the top of the stack. Is empty, checks if the stack is empty. Is full, checks if the stack is already full, given a certain size, right? Okay, and we I also read about recursion, expression evaluation and parsing, depth first search. Although these are like advanced stuff for now, because I have not learnt about these. Expression evaluation and parsing, I think this is what I was doing yesterday. But yeah, undo a redo operation, browser history, and function calls. Function calls also is important. Um, functions have to be. Oh, this is why it is called the call stack, right? When you create a function and you know you start executing code, right? That function has to be added to a stack, and the most recent call to a function is a call to any function is the execution of the function at the top of the stack. So yeah, which is why we have function calls here. That is good. We also have that's also basic stack data structure. So we oh wait, which one did I start with? Easy problems on stack. Okay, I didn't read this. Okay, what's this? Oh, okay, it's an operation. Yeah. Okay. Well. What does appending an item to an array really do? Right. So let's say we have. Let me clean this board here. Actually, I'll keep this board because I flopped in explaining this yesterday. But I'll just delete the rest. You know. So I said. So we know how do we implement the append, right? Append method or any other way to um, add an item to the end of an array. Well, if an array is of a size, let's say array x is of size 5, right? We can say x, array x length, right? Which is 5 plus 1. 1 should be equal to x, right? This. and then to add the item to the end of the array. This is what append is basically doing. Let me really test that to be sure. Mm, Otherwise, once the I'm just seeing how come I skipped all these. Oh, okay. Sorry. Mm, Basic operations that can be performed on a stack include push, pop, and pick. Here we read this. Array, using array and linked list. So there are two ways to implement a stack. The first way is using array, and the other one, the second one, is using linked list. Well, I've not studied our linked list yet, so I'm going to be using arrays. In an array-based implementation, the push operation is implemented by incrementing the index of the top element and storing the new element at that index. Yes, so I read this to understand that this what the append method does. So the pop operation is implemented by storing the element at the top, incrementing the index of the top element, and returning the value stored. Okay. Um. Yeah, that makes sense. Uh. So I'm not going to read everything because it's like quite intuitive, self-explanation, explanatory. But no, 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 no. I think I should read it. This is really important in actually understanding how you see stack is a linear data structure. I'm coming. All right. Okay. So where was I? I was thinking to skip all of these, but I think I need to read it and understand what is going on. Um, I really need to, because this is how you learn. So let's see. Stack is a linear data structure. Linear data structure means it increases with the input, right? It's based on the amount of items that are in the input. So, or the length of the array in this case. So the last element inserted is the first to be popped out here. Did I read this yesterday? I don't think so. It was a different page, but they kind of look similar. What is a stack? A stack is a linear data structure based on lifelong principle in which insertion of a new element and removal of an existing element takes place at its end. Oh, represented as the top of the stack. To implement the stack, it is required to maintain a pointer at the top, okay, of the stack, which is the last element to be inserted because we can access the element only on the top of the stack. Therefore, last universal principle, this strategy takes that elements that is inserted last will come out first. You can take a pile of plates, get on top of one another. As real life example, a plate. Yeah, okay. So a fixed size cannot grow or shrink dynamically if the stack is full and an attempt is made to add an item. It will overflow. Yeah, and an error. Okay. Yeah. Okay. Yeah. These are the basic operation. You're pushing to the stack. Uh, okay. Push before pushing an element to the stack. We check if the stack is full. If the stack is full, which means the topmost element in the stack is equal to capacity minus 1, then stack overflows. Stack overflows, and we cannot insert elements to the stack. Otherwise, we increment the value by 1, right, and add new value, and the new value is inserted at the top. Can we push to reach capacity of the stack? Okay. Um. Yeah, this is just simply the same as whatever I saw yesterday. So we have stack. Oh, I've read this yesterday. I don't know why. Uh, Let me come back quickly, wash my face. I'm feeling sleepy, but I don't want to sleep now, so I need to go push through this. Okay. So I had to go and wash my face quickly. So I'm feeling sleepy. Um. Yeah. This is not the time to sleep. Disadvantages of an array implementation. Um. Okay. It is not dynamic. It doesn't grow. And shrinking is depending on needs. Blah blah blah. Or in case of dynamic size array, like vectors and list in Python, array list in Java, stack can grow and shrink with array as well. So here's an implementation of a stack. So we have stack, create the stack, right? Python 3 says max size. Okay. How is max size being used? Sales tier, import max size. Hmm. I don't really know what linked lists are, so I'll just leave that for now. Um, I think that's all. So advantages of Stack simplicity. They are simple, right, and easy to understand data structure, making them suitable for a wide range of application. Push and pop operation on Stack can be performed in constant time. Yeah, we know that. Mm, well, I don't think. Let me go back again. I'll need to check my stream if it's working. Otherwise, I'll have to. Okay, so right, forward and backward features. That's true. I think. Hmm. Can simulate some, functionality like this redo and undo feature. Try and do that. Because I clicked on this link before, it showed me red. So let's go back to this page where we're doing the conversion of an infix. Right. So I'll try and solve this question again. Although I read it yesterday, but let me see how I'll be able to solve it today. So basically, write a program to convert an infix expression to a postfix form. Right. Infix expression is an expression in the form of a operator b, like this, when an operator is in between every pair of operands. Postfix operation is the expression, sorry, postfix expression, you know, is in the form of a b operator, right? When every pair of operand is followed by an operator. When every pair of operand is followed by an operator. Okay. Every pair, well, might not always be every pair. So let's use this example, right? I would like to use my own examples again. Let me come back here, right? So in this case, we want to transform a string from one form to another, and also respecting certain rules, right? So we know that operators have precedence over other operators. Some operators have precedence over other operators. So in the case of this multiplication sign and plus, the multiplication sign has higher precedence um, over the plus sign. So in the case of a plus and minus, a plus and multiplication sign, the multiplication sign always has to be on top of the plus sign. So when we are looking through the string and we find a a test, right? I'll just remove this again. I'm not going to remove it because I want to compare it with my answer. So I'll have a postfix, right? This is my new postfix. It is an empty string for now. So let's do it this way. I'll create another stack where I'll be storing all my operands. I'll call this ops, right? Up stack. Let me just put the up stack here like this. Now when I see an A, I want to put the A here because it is alphanumeric character. So I'll put A there. Sorry, I'll put this. I'm looking at these strings, not the one below it. So um yeah, when I see an A, I put it here. When I see a plus, I put it here. When I see another B, I put it here, right? And the next item I see is a star. So I want to add a star on top. That is acceptable, right? Now the next item I see is a C, but this time around I'm seeing the next item is a star again, but already I have a star in my stack, right? Or a multiplication sign in my stack. So what do I do in this case? Well, in this case, I will have to clear the stack so that my current biggest sign is at the top of the stack. So I'll have something like this. I'll have a star and a plus in front of it, right? Because the star has to be popped first, and once it is popped, it is going to be the first to be added to be appended to the postfix string, and the second one too will follow again. We'll pop this one and add it here, right? Before then adding this one onto the stack. So after removing all of that, I'll just do it this way. The stack is getting full. Then I want to add a star here, right? So after removing every other operator that was in the stack, I want to add the new operator onto the stack. Then we continue doing that again. We see F, but this time around we see another F, another star. Sorry, at this point here, we want to put the F here, and then sorry, we want to put the star, the old star, because two stars of the same types can't stay together. So the we have to clear the stack for another operator to come in. So here's what we're going to do. I'll take the former one, remove it again, and put it here, right? Before carrying on with the next one, which I'll put on the stack. And then the next item is an E, right? So I'll put an E here. The next item will be a minus. We can't have a minus of on top of sorry, did I skip D? Oh my god. Um okay, so D D should be somewhere here because it was after F. It was before F. So D should be there. Then we can now have the next item, which is this minus sign here. This minus sign here has lower precedence over the our current star, so we can't put it there. We need to put the minus here, right? And then we need to take out whatever was there before. I'll put my asterisk here, right? I'll put the asterisk there. Which am I even looking? Oh my god. Um. Anyways, I think my eyes are really. Let me just wash my face again and take some tea. Okay, I think I should be okay from now. I I have gotten my my tea, very hot water. I was really sleepy, you know, and I can't sleep now. Yeah, when you're sleepy, a simple tea can just do the trick, right? You don't need to drink coffee, just hot water. Oh, so that you can carry on studying. Here's my Egyptian mug. I don't know. Yeah, you can see it like this. Okay, I'm so sleepy. Hold on, apps coming. Okay, I think now I need to have more water. I can relax now. Where was I? I'll need to clear this board and go over it again. So let's start with this one. A postfix, the infix expression to postfix expression is basically, you know, um, an interpretation of how humans will perform um, an operation um, compared to how computers would normally perform these operations. So it's not a comparison per se. It's just translation. Yes, a translation of how we normally perform calculations against you know the conventional way of how computers perform their own operations, because it is not quite straightforward for computers to understand, as the article says here. I think why postfix expression, the compiler scans the expression either from left to right or from right to left. Consider the expression a plus b times c plus d. The compiler scans the first scans the expression to evaluate uh, b times c, then again scans the expression to add it to then again scans the expression to add it to it. Okay, so after perform this b times c, the compiler scans the expression and then performs any other operation and adds it to this b times c. Okay, the result is then added to d after. Okay, after another scan. Oh, okay, so it does b times c and adds it to d, right? Or it does b times c and then adds the a, then d at the end. Well, either way, it is not quite straightforward, right? The repeated scan makes it inefficient. If fixed expressions are easily readable and solvable by humans, whereas the computer cannot differentiate the operator and parentheses easily, so it is better to convert the expression to a postfix expression, right, or a prefix expression form before evaluating. Does this really work in terms of code? Let's say, so this is the result of this one, right? So I'll do it that way. I'll say, nah, this can't work. This is not the same as this. Where okay, let me see if it does work. So where's my playground? So I have my playground here. My playground has what? Here, valid palindrome. Oh, valid palindrome does not have anything in it. A valid palindrome is a word that can be read in both direction, backwards and forward. Right. And we were able to solve this question the other day. I was really excited about it. Yeah, this is good. Okay, so in the playground, if I had x is equal to 1 plus 2 times 6, right? What did you say? Times 6 plus d plus 1, right? And then I have y. The postfix version of this will be 1, 2. You see, this doesn't make sense at all. Or what were they trying to do? Hold on, let me just try it first and see. If I had 1, 2, or comma, because this is not 1, 2, that's 12. So let me do it that way. I'll just say comma. I just want to try it and see if this is actually the interpretation. We are just representing how the operation would have been done. Sorry. So Let me just take this to this side here and I'll copy it quickly. So C is 6 times um plus 1. Is this valid? Let's print x and then print y. Can print y. Okay, so let's run this. Of course, this will not work the same way. Well, maybe I'm just misinterpreting it, but here is a postfix conversion of this infix expression, right? And how is this postfix conversion done? Well, we use stacks, right? We use stacks, and I think on both sides, right? We are stacking, onto the output, and then we are stacking the operators as well. So here's what is going to happen whenever we have alphanumeric values, right? So I'll call this results. I'll call this results here, right? Result is equal to a string, or we can even use an array. No worries, let's use an array. So whenever we see alphanumeric values, we want to add it to the stack, right? The result stack. So I'll just put result stack there, or results for short. And then for the operators, right, I'll use this for up stack, like this, operator stack, and is equal to something like this. So here's what you're going to do. So when we see a plus here, we want to add it to the stack here, the operator stack. Now we see another B again, so we add it to this result stack, right? We add it to the result stack, and the next time we see another operator, right, we also want to check what was there before. So we have a plus here at the top of our stack. Since it's the only item in the stack, it's already at the top of the stack. So what do? We check if it's uh, if it has a higher precedence over the next operator, which is this star here. If it's not, we add the star on top of the stack. So yes, it is not. We add the stack here, the star here. Then the next item we see is a C, right? A C is alphanumeric, so we put C here. The next one we see is a plus, right? This plus here. Now, what happens when we see another operator? Yes, we need to check with the topmost item in the stack before adding it on top of the stack. So the precedence of this plus here is lower than that of this star or the multiplication sign. Therefore, we want to move everything that was previously in the stack before adding the um, plus sign or the current operator, which has a um, lower precedence, right? So we remove everything. So we add it to this place. We remove. Let's cancel it. First of all, we want to pop from this stack. We always do LIFO or FILO operation. So we remove the first one. So we remove this from here and we add it here like this. And then the next one will be plus. Then we remove it and put the plus here, right? So before we continue with the plus here, then before we add it to the stack, we'll now add it here. So it will become the next item at the top of the stack. These, let's assume they were not there. So this plus here will go to the bottom and it will be there. So, and in case we see any other operator after an operand, then we add it to the stack. So here D will come here. This will be D. Let me use a different value. So our D will be here, and then the next item in the stack, well, we don't have any item in the stack, so we want to take the topmost one in the operator stack and append it to our postfix operator. This is the postfix string, postfix string, And here is our result. This is what a postfix and an infix string is. And I think there's, another question that asks to convert back a postfix. A postfix to an infix. How do we do that? Let me just make sure that I see the question actually exists. Da 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 da. Yeah, prefix. It's not even postfix. It's prefix. Prefix. Interesting. An infix expression is called the infix expression if the operator appears between two operands in the expression, simply in the form of operand 1 and operand 2. So we have an example such as this one. So let me punch my chest. So an expression is called a prefix expression if the operator appears in the expression, right, before the operands. If the operator appears in the expression before the operands. Wait, so we have this example here. An expression is called an infix expression if the operator appears between this and this is an is an infix expression. The entire thing is also an infix expression. Now an expression is called a prefix expression if the operator appears in the expression before the operands. Oh, okay. So this like an inverse of a post of the postfix. Okay. This makes sense. So prefixing convert it into an infix expression. So usually does the computation in either prefix or postfix. For humans, it is easier to understand an infix expression rather than a prefix expression. Hence, conversion is needed for human understanding. So these star and plus, right? They come, after before the operands here. Okay. Yes, it kind of makes sense. Um, how do I convert this? I can try the conversion out and see. Again, we'll have stacks. So let me come here. I'll use a stack here. Let me just. Okay, let's just change the color a little. So let me convert this to a post. Let me just attempt it to convert it to an infix expression, which humans understand, by the way. I don't know. I'm so tired today. I feel really, really sleepy. If not because of this tea, I would have fallen asleep. So we'll create this time around. We'll do it the other way around. So we'll create a stack for our operators and another stack for our operands, and then combine later on. So here's what we're going to do. So first of all, since the operators have some form of precedence rule, we want to do it separately. So the first one, I'll just create another operator stack here, up stack here, and set it to be equal to something like this again. Now, this time around, when we are going the other way around, I think we should just appreciate that the inverse will happen, right? So when we are looping through this prefix string, this star is our first item, so we'll put a star here. The plus is our second item, then we'll put a plus there. So we see an A, we put it in a prefix. We just put A here. In an infix string, I'll just call this. Let me just change this to if infix string equals to this. So this is going to be A, so we'll have A here, and then the next item will be B. Okay, but now we see a minus. Hold on. Oh, I see. When we see an A, we put it here, right? But when we see another B, which is an alphanumeric value, we don't want to add it to the previous one. So we look in our stack and we find the topmost operator. If it is a plus, then we put it here like this. We put it here before we continue to B. Then we'll have to do so we see another operator which is also less than okay, this is confusing. I'm confusing myself. Oh god, I'm so sleepy. Let me go back and read this again. So read the prefix expression in reverse order. Oh, from left to right. We're doing from right to left, right? Hold on. Nah, doesn't work. Doesn't work really. Okay, what if here? I'll just take this out. And I'll start here. I'll see instead of having a precedence rule for the operators here, I can do something like this. I can just have I can just have the first, let's say operator stack, right? I'll use an array this time around, so I'll just put the star here and put the plus there, right? Then I'll have another stack for the operands. Okay, so when I see an A, right, I'll just put the A here. I'll just put if is equal to this. The A will be here. When I see another, non an alphanumeric value, then I want to check what is at the top of my stack. So it is a plus, so I add it here. Then before I add the B, right? Next time I go, I'll check what is at the top of my stack. But because this is, in an inverse form, okay, this is not coming. I don't know why I'm sweating. Understanding this thing would really go a long way. It will really go a long way. And I don't want to solve any lead code questions yet. I want to get this operation properly. Okay, so let's read what the algorithm does. So giving an a prefix expression converts to an infix usually computer blah blah blah. Hence, so this will be the postfix. Okay, this will be the infix version. This will be the infix version. Interesting. So from in reverse order from right to left. I've been doing from right to left. Oh, the symbol is an operand. Uh, the symbol is an operand. Then push it. If the symbol is an operand, then push it onto the stack. Mm. Oh, okay. Yeah. Okay, that makes sense. Um, this is the Python implementation. So we start from the, you know, from the end of the stack, and we do some string concatenation. You know what? Let me implement the postfix algorithm first. I'll come here, create a folder called stacks. Yep, and put in new file infix to post postfix postfix. Oh yeah, always do that. Oh my god, my eyes are closing. I know, gotta keep studying. I have to keep studying every day, every day. So if I was asked to implement the postfix and prefix algorithm, how would I go about it? Well, that is the question I need to solve today. Although I understood how it works, but I've not yet implemented it to be sure that my solution works. But I'm pretty confident that that is how it should be done. When you see um an operand, an operator that has a precedence which is lower than the current operator in the stack, then you empty the stack first before you empty the stack into the postfix string. Yeah, I think that's how. Um, So I'll define different steps to do this. First of all, we want to loop through the string, right? We want to loop through the string, and also we want to see if the string is the current item in the string is alphanumeric before we add it to the the original postfix stack. So here's what we're going to do. I'll create a class, right? Sorry. Now I'll be creating class for my solution. The class, I'll call this infix to postfix, right? Okay, this will be my class, and I will create two functions to begin with. Why do I need to create a function? I don't even need to use a class. I'll just create one single function that takes the objects or the parameters to perform the operation. um because if I create a class now, I will need to instantiate the class and use a function out of it. So I don't want to use a class, so let me use a function directly. Oh, I shouldn't have done that. I'll just change this to a function. So I'll define a function. This function would take a string, right? So I'll just say s is equal to str, right? And then we want to return some value. So first of all, what I would do is to create the postfix stack. I'll just call this postfix stack. Postfix stack. Right. This is going to be an array, an empty array. Now, first of all, I need to gather every item in the string that are not an operator. So I want all operands. So here's what I'm gonna do. I'll say so yeah, so for I in range right, in range of the length of the string, length of s, right? I want to do postfix stack dot append, or you can do postfix stack the length and then we always append to the end. But anyways, that's another story on its own. But yeah, we can do something like this and it will still append it. So we'll say string dot length, right, s dot length, right? So this is s dot length minus 1 equals to s. Let me test this out to see if this will work. Infix, I'll just return postfix stack, which is what we want to. I just want to test this out and see if it works. Return postfix stack. So I, small I, and then print. I'll just put in my favorite values. Let me go the way here. So I'll copy what's here. Oh, shy. Okay, what streak do I want to use as an example? I had the streaks here before, right? Don't I? Didn't I have them here? This is not my string. Where is it? Convert. Okay, yeah, this is my string here. Right. So we have something like this. So if this worked, then we'll see A B C D instead of the operands in the middle. We'll just see A B C D. So here, uh, so here like this. Well, this will append everything because I'm not checking if it's alphanumeric, but let's see if this works. Okay, so uh, is equal to SI. I don't see any complaint about, you know, the stack, but let's see. Oh, unbound local error. Yeah, I see. Cannot access. What if I do it this way? Will this work? Yeah, it can't work like this. Alright, alright. Makes sense. This makes sense. Anyway, let's go ahead and append. So I'll do postface stack dot append. Want to append in the S at I. Hold on. This error wasn't even about. Can you imagine? Okay, that was correct. Let me read the error again. How? What am I doing wrong? I'm not sure what it is. Honestly, I'm sleepy. But yeah, I need to get this one done. You know what? Let's just remove these types here. I don't want that. Interesting. What's this error saying? Let me read it again. Print postface error. Okay, so the construct append. Wait. Oh, Jesus Christ. I think that might just cause, you know, okay, we can't get the other ones. I'll still want to try that and see if this will work. S dot, let me see, S here is an str, so S dot, oh, so len of x, n of s here. So the length will be at the end, so n of s is equal to, the value at this point will be equal to s at I. S at I. I just want to see if this works. It doesn't, so it's out of range. But if I did, oh sorry, I did s -1. Yeah, this might work. It didn't. It will still be out of range. Okay. Well, it's always good to try something out. Yeah, so like this now we are appending item to the string, but we don't want to append stuff like this. We want to append only when it's alphanumeric. So if s at I dot is alpha num, right? Christ, why am I putting parentheses here? This is not JavaScript. Okay, if it is, then we want to shift this here. Okay, let's run this. Right, so we have ABCD, that's our string, but that's just one part of the puzzle. We also want to be able to add items to another stack. So let's say we have a an operator stack, operator, right? Operators. I'll use operators. Operator stack. Christ. I don't know why I don't type very well. I think this don't follow. This is blocking me. Let me just put my computer like this. Excellent. So I'll just do close. Oh my god, close the program. God. It is here. Just go away. So this will be our stack, and our stack will also be an empty array. Now, well, before we we append a string, right? Well, if it's not alphanumeric, then it must be an operator, right? But we also want to know the type of operator it is. Each operator has precedence over the other one. So how do we represent precedence in this case? How do we represent the precedence? What if we use like what if I use like an if else statement and say, you know, if so else, right? Else I go if the string, s at I is equal to a plus, right? Is equal to a plus, then we want to add it to the stack. So we'll just say operator stack dot append s of I. What if we want to do it this way? It's going to work, but there's an issue with this, right? I'll have to write it all over again, all over for the other operators. So how do I do this in a way that is, not verbose, and also doesn't take too much time to finish? I mean, in terms of time complexity. Mm, I'm still thinking. Okay, so since each operator has a value, I mean a precedence. Basically, operators like you know plus. Let me just put a comment here. Plus, minus, and which one again? Plus and minus are equal. They have the same precedence. But operators like star, which is multiplication, or division, also have the same precedence but bigger than uh, the other one bigger than plus or minus. Right. That's 1. So let's start with this 4 here. Plus minus and you know and division. How do we represent this? I can't think properly. What if we also have like something like parenthesis, right? Like this. And this I'll come to this later, but let's do the other two first. Well, for plus and minus, since they have the same, level of precedence, want to keep we can say both of them are at level 1 and this will be level 2. Okay, level 1 and level 2. Well, I can create like an operator map. Always use the map. I like maps a lot. So I'll say if the operator is a plus, then we want to give it a 1. If it is a minus, we want to give it a 1 as well. If it is a star, which is multiplication, I want it to be 2. And if it is a division, I want it to be 3. I want it to be 2 as well, right? So this will work. I think it will work to some extent, but let's try it out first. So I'll say if s of I, right, is equal to this, so we can just use this and check if it is an item in the stack, right? So we can say if si is in the stack, si is sorry, we will check the presence of this in our map. So we'll say operator map si like this. Then we'll see, we'll begin to append this to the operator. So I'll just put this like this and say return it with the operator stack, just for us to visualize what's going on. Okay, so there's an error. It says what am I doing? Let me just put this on an array. Oh, it says here's the error. Yeah, key error. So this wouldn't be a string. Are you kidding? This is interesting. Okay, so this work. There's an error again. But you know, oh, I'm using Okay. Well, this should have just said it is not now. Why are you appending it to why you even checking it is okay, if I said if this is not empty, right? I'll say if this and that, yeah, then do this. Okay, the error is still there. It's not empty. Hmm, interesting. It's not an empty space. How do you check is an empty space in Python? I'll come back to this later on. I don't know how to format this canvas. Let me see. That was how I formatted it, but yeah, here we are. Okay, so if it's not, we want to add it to our stack. So how many items do we have in the stack so far? We have 3 items in our operator stack, which is true. We have plus, star, and plus again. Okay, so how do we begin to add these items to the stack? So we've done two of the most important parts. At least that's how I do my stuff. There has to be some planning to it. So let's come back here. Is this a valid comment in Python? Nope. Uh, I'll just go here and Google it. Okay, 3 quotes. How to create a multiple. Yeah, try this out now. It didn't work. Oh, okay, 3 comments. Great. So I'll just do that now. 3 comments, 3 strings. So can do 1, 2, 3. Yep. Oh my god. So sleepy. Oh god. Let me finish implementing this first. I think I can. Showing up is important. So, first of all, um, group. I'll say get non. Uh, get alpha numeric. I'll just say alpha numeric in one stack, and the operator value in the operator stack. Operator stack. Good. Now, what is next? We want to be able to, combine strings, right? Based on the operator's precedence value. So here's what we're going to do. I'll take so before we even add an operator to the stack, right, we need to check whether there's already an item in the stack and compare the value of that item. Otherwise, we'll just do this. Okay. So let's start with that. I'll just go this way. I'll say if first of all, is there anything in the stack in the operator stack? Operator stack. I have to check first of all if the stack is empty, if it has any current item in the stack, right? And we can do that here. We can do that here like this. We'll say if the current string is, yeah, I would, and is an empty space alphanumeric. Let me, instead of doing it this way, right, I want to check print. Nah, I can do it here. I can do print the is alphanum. If this is true, it's not, it is false. Good. Well, I don't know what I'm doing. I think I should end this stream. Um, I'm really sleepy and I can't really think straight. Nah, I'm not going to end it. I'll push through. Um, I know what I'm doing. I know what I'm. So, hold on. Get go out of that. So we have here. So we want to append if it's not an empty string and the operator is in our map here, right? Before we append the operator, we need to check what kind of operator it is, right? And also, we also need to check, if we also need to check if the operator, if there's already operator in the stack before we add an item to the stack. So here we are checking if the current item in the string is an empty space and the operator exists in our map. This exists in our map. This will return either true or false. Same thing for this one. But if either of them returns false, then you know we don't perform the operation here. Okay, so when and the operator is in the string, then what do we do? Honestly, I don't know what I'm saying, but I'm just really sleepy right now. Let me wash my face and come back one more time. Shooting for the stars. It is cold now. Alright, I've refueled myself. So these are our operators that are. Look at where I put this equal sign. It should have been in the middle. Okay, doesn't matter. So for now, we know how to group operators, right? And we know how to push um, to put um, operands in their operand stack. So here's what I'm going to do next. I want to put operators based on certain values, right? I mean, based on their precedent value. So already we know we can stack a star on top of the plus. So let's do it this way. Now we are checking if the correct operator is not empty and if the operator exists in the map, right? Now before we begin to add items to the stack, we also need to know another thing. We need to know if the operator we need to know if the operator has, I mean, if we already have an operator in the stack, right? So here's what I'm going to do. I'll say if stack, right? If stack, right? And oh, sorry, operator stack. So meaning if there's an operator in the operator stack and operator stack and the last item in the operator stack value, right? So I'll take the, so here's what I'm going to do. I'll say I want to check if the last item has a value bigger than the correct one, right? So we know that we have, in the case where we already have an item in the operator stack, we want to check the topmost one. Does it have a precedence value bigger than, the current item in the infix string, right? So let's say we added this, we need to check this, but if in the case where we don't have anything in our stack, we need to put this into the operator stack. But when we get to this point, we need to check, does an item exist in the stack already? Yes. What is the the value of that item in our map here? Well, plus is 1, right? So, and what's the value of this minus here? The value of minus is 2, meaning we can stack um s on star on top of plus, right? We can stack star on top of plus, but in the case where it is inferior, right, we need to clear the stack, append it to the string before putting this on top of the stack. So here's what we are going to do. I'll say now, I'll say if there's an item in the stack, and the value of that item is less than the current item we have. So here, to get the top item in this stack will be operator stack, right? Length of the operator stack. These names are just too long. -1, right? I don't know why my editor doesn't break the lines. Let me see how to format. How to format. How do I format stuff? So to format code item, you can select a fragment, then go to create format. How to format code. This I've tried this before, but it doesn't do that. So here's what's going to happen. Settings. I can do it this way. Yeah, let me not waste my time on this. So I'm getting the topmost item in our stack, right? Instead of calling this operator stack, I'll just call it up. Hey, sorry, I want to replace this everything. I want to replace it with um sorry, it's not this. This is not how you replace stuff. The string is just too long. So replace everything here. Up stack like this. Yeah, replace all but with up stack. Okay, this is fine. There's no error yet. This is not an error per se. So we are saying if the stack is not empty, right? Take let's take the topmost stack, right? Right, the topmost stack. So the topmost item in the operator stack, and then we'll find its value inside uh, our map stack operator map here. And if its value is superior to the current one, the current um, operator that we have in the iteration, then we append it to the operator stack. So here's what we're going to do. I'll say if operator stack, right, if it's not empty, and the topmost one, so we want to say um how do we get this? So we'll say the current item in the iteration, so s of I. So map operator map, right? Operator map at this point here. Operator map at s of I. Okay. If the current operator is superior to um the topmost item in the stack inside our map, so we'll just look the operator map again, and we'll get the topmost item here, right? If it's superior to it, why do I still have this open? Okay, good. If it's superior, then we want to add it to the stack. So if the stack is not empty and the current item's value in the map is superior to the the item at the top of the stack's value, so this will get us the last item on the top on the stack, but we also want to see its value inside this map here, so which is why I added this here. And then if it is, then we want to append it to it, right? If it's superior, we always want to put superior ones on top. But what if it is not? And what's this doing here? Hold on. If s of I is not equal to, is not empty, and s of I is in the map, well, we don't. I think this here is valid, but then again, you know, it doesn't. Does it really make sense to be here? I want to append s of I in on top of this. That's the only condition for items that are superior. But in the case where, okay, I'll say else. Now this else will mean this condition here is is not correct. So else when the stack is empty, right? What do we want to do? When the stack is empty, we want to append item to the stack. So I will just say else opt stack dot append the current item to the stack, s of I. I mean, this will still print the same thing. Nothing will change. But we want to do something else, right? Now, when okay, so we can say else if, right? Sorry, elif, elif. I'll just put a pass here for now, and I'll say elif what? Elif if there's an item in the stack, up stack, right? And but this time around, you know, this condition is not met. The item is now inferior. I'll just copy this. Right, the item we have now is not inferior to the one on top of the stack. So here's what we'll do. We want to empty inferior or equal, right? If it's inferior, if it is equal, we want to remove everything from the stack. So let's do it this way, right? The same items. So here's what we're going to do. How do we empty the stack? We want to empty the stack. Want to empty the stack as we go. Oh, my time is up. Well, let's get another 10 minutes. I'll just put like 20 minutes here. Oh, 15. 15. It's okay. Well, in the case where we only want to append when it is the stack is not empty and the operator is bigger than the topmost one, right? Topmost one in the operator stack. But in the case where the stack is not empty and the current operator is less or equal to the item in the topmost stack, we want to empty the stack. And by emptying, we want to empty the value into our postfix stack here. So how do we do that? How do we continue, empty the value? How do we empty the value? If we run a loop on top of the stack, we can be removing the stack, but removing item from the stack means we are changing the stack's length, right? And a for loop with range may not work with that. So how do we do it? Ah, okay. So let's run a while loop. While the length of the stack, right? While the length, let's find a variable. Let's call this um end, right? I'll just call this the end of the stack. I'll set it to be the end has to be 0, right? Which will be the topmost end. So I'll say while um the length of the operator stack is less than, is superior to the end, right? Is superior to the end. We want to remove an item from the stack. So we'll say um, top, I'll call this top, right? Top is operator of the stack dot pop. We only want to do pop. So we pop one item and store it to top, but then we want to pop that we want to add that item to our postfix stack. So I'll just put postfix stack dot append top, right? And this, every time we append something to the end, it will always reduce this value here. Yep. Okay. And then we will now add the current one to the stack. So after that, we'll just do, after this is done running, we'll just do opt stack dot append this current string s of I, right? This is what we should do. And I think this will work, right? Good. So this worked for A, B, C, D, but the last item is not being added. So how do we do that? So we'll still have, at the end of the day, we'll still have one item left in the stack. So, well, if this length of the stack is still superior to 0, the operator stack, we just want to pack everything out. That means at the end of this whole operation, right? The time complexity for this operation will be bad though. It will be absolutely bad. So here is what we have. Let me close this quickly. I'll just close the terminal from this side. So we want to add the last item to it. So here's how we're going to do it. I'll say um the postfix stack. So if this is still superior to 1 at the end of this operation, right? If it's still superior to 0, then we just want to unpack everything into it. And how do we do the unpacking? Well, we want to add at the end. So at the end of the day, it will remain either 1 or more, right? So I'll say for I, so a separate up loop. So for I, for let me just say for j in range, the length of um the operation stack, right? I just want to do postface stack dot append the option stack at j, so 0 and 1 and everything. Yeah, so here's our final results. For now, this does not really respect everything, and then we want to pop the item after appendage. So post operator stack dot pop again. Yeah, so yeah, the operator stack will be empty at the end of the day. So this will be our, so we don't want to return it this way. I'll just do it like this. Hey, just come here. Christ. Return. So we need to transform this into a string. So in Python we'll do this dot join everything to postfix stack. Yeah. Yep, this is our result. This works. But it doesn't really respect all the rules, because in the case where we have parentheses, right, we also want to do something else. But yeah, this works for now. It actually works for now. So I have to break it down and actually understand the steps taken to achieve something like this. Get alphanumeric values in one stack and the operator values in operator stack. So create a map for operators, operators, right, versus, so operators versus um precedence value. So it could be anything from 0 up to n, right? Let me just use some 0 to n. Compare current operator in, why am I typing like this? Compare current operator in operator in the operators. Oh, come on, operator map, right? Map and append to operator stack based on precedence value. Yeah, I think this is the solution, but I've not added support for parentheses. I'll do that tomorrow. Yeah, I've done more than 1 hour now. So I'll push this to GitHub. So yeah, let me push this to GitHub and share the link in the description. So I'll go to terminal. I want git bash. I want to git add, git commit dash I'll call this stacks. Let me just do it this way. I'll do day 11. This will be mine now. Day 11 stacks. Stacks and what? Stacks dash infix to. Okay, let me do it this way. Stacks infix dash to postfix operation, right? Infix to postfix. This is okay. Committed, and then git push origin main. Yeah. Okay, so I'll copy this link and put it in my description. Yeah, so I'll continue tomorrow with the problem.